Hello everyone, good day and welcome to this wonderful episode of statistics video tutorial. I still remember when I was in school taking up my degree in statistics. And I terribly missed the traditional method of teaching, wherein my professor was trying to teach how to calculate or compute a statistical test without the use of a computer software. I am very much thankful that I was able to experience this way of teaching because I was able to understand the concept and rationale how the formula was derived. All right. So this is a lecture of a multiple regression model used done by Mr. Takashi Yamano. All right. So because of the utilization of computer software, there are other steps and procedures which often neglected. All right, so which often neglected and set aside. In a machine learning model such as multiple regression, it is a must to understand the behavior and pattern of the data before performing the modeling part. One should test the assumptions involved in machine learning model. If any of the assumptions is or are violated, it is predominantly important to address such violations, to fix the violated assumptions, and once it's done, then it is the time that we can start building the model and choosing the best model. One effect of using a computer software is that the people might forget how to compute statistics manually by following the formula guided procedures, such as calculating the sum of square regressions, sum of square residuals, the mean square regressions, the mean square residuals, the F ratio, etc. This is one of the main reasons why some of the analysts nowadays fail to understand or don't understand the behavior of the data. If, for example, what will happen to the R square change or R square if you remove one of the independent variables? Will it go high or will it go down? If the R square change go down or go up because of the removal of one of the independent variable, what does it mean? Is it good or bad? Does it affect the accuracy or reliability of the model? These are the things that we should consider if we want to build a highly reliable and valid model. Alright, so in this video, I am going to discuss few of the concepts and steps to calculate a multiple regression. I will going to discuss and show how to do a multiple regression using the IBM SPSS software, using the Microsoft Excel data analysis add-ins, and of course, using this matrix algebra procedure that I am showing you in the screen right now. Yes, so we will going to show you how to calculate multiple regression using this matrix algebra. Okay, so as you can see, this matrix algebra is has 29 pages. Yeah, but I'm going to simplify this in few steps. Okay, so don't be afraid of the equations, of the formula being discussed in this module. Alright, so I will going to simplify all of this later. Alright, so okay, so let's proceed with the SPSS. Okay, so okay, so I'm going to use this data. Okay, I will going to use this data. Okay, I'll be removing this one. Okay, so what you can do is go to analyze, go to the regression and choose linear regression, and then put the variable y on the dependent variable column or area, and then place all the independent variables to the area for the independent variable. And then in the statistics tab, you can choose what are the statistic that you want SPSS to compute. Let's say, for example, the Durbin-Watson, if you want to test the residuals. If you want the SPSS to include the R-squared change, the descriptive, the collinearity, and so on and so forth. Okay, so but for now, that is not part of our discussion. What I'm going to show you is how to calculate multiple regression using SPSS. And then there are other options. You can use choose plots. So you can choose what to plot, whether the histogram and the normal probability plots. You can also save, and then you can also have these options. And the other style, table style, and then the bootstrap modeling. All right. Okay. So once you already move the dependent variables to the dependent area and the independent variables to the independent area, you may now click the OK. And this is the output using the SPSS. Okay, so as you notice, no, it is pretty easy. No, it is very easy to compute statistics using this software. Very straightforward, and Okay, so the thing is, later on I will going to discuss what does 0.256 mean in the analysis of variance. What are the coefficients, and what is R square, adjusted R square. So this is what I already discussed a while ago. Okay, so later on I will be showing you the definition and how to interpret this output. All right, so this is how to calculate a multiple regression using SPSS. All right. Okay, so let's copy this later. Okay, so these are the variables. So I'm going to copy this because I wanted to replicate the data. Okay. And okay, so I will be using this one. Okay, so I'm going to remove this first. Okay, so what we're going to do when we are using the Microsoft Excel data analysis add-ins, here's what you can do. You can go to data and then data analysis, and choose regression. Okay? So once you choose the regression, click on OK, and then highlight the y variable. Okay? Move your cursor to the area, and then highlights this B1 to B11. And as you can see, since I also included the header or the title of the variable, so I must take labels. Okay? And of course, for the x range, or these are the independent variables. So I'm going to remove this first. So here's what you can do. Put your cursor here inside the box, and then highlights x sub 1 or C1 up to E11. And then for the output options, so you need to remove this one. So you have the options where do you want to put the outcome of the Microsoft Excel. Okay. So in this exercise, I'm going to show you. Okay. Okay, so we're going to put the output here, and then let's click on OK. And this is the Microsoft Excel analysis, data analysis toolpath. Okay, so the p-value here, it states that, okay, so let's check. Okay, I'll try to again. Okay. Okay. So let's compare the results using the SPSS. Okay, so the intercept is 7.965. The intercept here is 7.965. The x sub 1, 0.190, 0.189, or if we rounded it this up, okay, so how many decimal places? Uh, 0.190, negative 0.656, and negative 0.377. So the results is just the same. Okay. And now, I am going to show you how to calculate a multiple regression in Microsoft Excel using matrix algebra. So the matrix algebra that I've shown you a while ago is in the PDF. Okay, so remember that. Okay, using this method, I am going to introduce. Okay, so I'm going to use this template to introduce the how to calculate the multiple regression using matrix algebra. Okay, so alright, so I am going to introduce certain key terminologies such as the matrices, the inverse matrix, transpose of the matrix, and the vectors. I am also going to introduce certain functions such as transpose, m-mult, and m-inverse. These are the functions we will be using for us to calculate the slope of the x's and the intercept in a multiple regression model. But before that, we will discuss further about multiple regression. Alright? So, let's proceed first to the lesson that I've created. Okay. Okay, so before that, I'm going to introduce myself. All right. Alright, so I am a data scientist by profession with more than 18 years of experience in technology and analytics. Alright, so you can read this later on. Alright, so multiple regression is a predictive modeling technique and is an extension of a simple linear regression. It is used when we want to estimate or predict the value of a variable, dependent variable, based on the value of two or more other variables, which are the independent variables. The variable that we want to predict is called the dependent variable. So sometimes this is called as the outcome variable, the target variable, or the criterion variable. So don't be confused, guys, no? So when we say dependent variables, this is the same as an outcome variable, a target, or a criterion variable. All right? The variables we are using to predict the value of the dependent variable are called the independent variables. So sometimes this is regarded as the predictor variable, the explanatory variables, or a regressor variables. All right? So to put it in a more concise, or to make the definition more clear, for example, we could use multiple regression to understand whether an exam performance of a student can be predicted based on the number of the revision time. Meaning to say, a lecture or topic was more thoroughly discussed over and over until the students were able to understand the concept of the topic. Another independent variable that we need to include is the test anxiety, the lecture attendance, and the gender of the student. So we will going to use this independent variable to predict the exam performance of the student. Alternately, you could use multiple regression to understand whether daily cigarette consumptions can be predicted based on the smoking duration. Age when started smoking, the smoker type, the income, and the gender. Multiple regression also allows us to determine the overall fit or the variance explained of the model and the relative contribution of each of the predictors to the variance explained. For example, you might want to know how much of the variation in exam performance can be explained by the revision time, test anxiety, lecture attendance, gender as a whole, but also the relative contribution of its independent variables in explaining the variance. Alright, so these are the assumptions. Okay, so these are the assumptions that we need to test, or we need to use. Okay, so there should be a linear relationships between the dependent variable and each of the independent variables. So meaning to say, if you have three independent variable, each independent variable should have a linear relationship. There should also be a linear relationship between the dependent variable and the independent variables. Okay? The second assumption is that the data pattern should exhibit homoscedasticity in variances. Make sure that the variances along the line of best fit remain similar or constant along the line. Okay? Remember that. There should be a homoscedasticity in the variance. Okay? The variance should exhibit a constant value along the line. Third is that it is a must that your independent variables does not have multicollinearity. Meaning to say, your independent variables should not and is not highly correlated with each other. Okay? So, meaning to say, if your independent variables are highly correlated with each other, meaning to say, there is no distinction or difference among these variables. So, why are we going to include these independent variables when in fact these are almost the same variable? That's the meaning of multicollinearity. You should not allow, or you should not, include an independent variable that has a multicollinearity or that has a strong correlation with each of the other independent variable. There should be no significant outliers. So there should be no significant outliers, meaning to say there are only acceptable percentage of outliers in the data. As much as we can and as much as possible, maintain the lowest number of outliers, because all of the data or most of the data has natural outliers. So as long as the outliers is not significantly affecting the distribution and the trend of the data, that is okay. Okay, so that is why there should be no significant outliers, or there should be only a minimum number of outliers. Okay? The residuals or errors should be normally distributed. Okay? The residuals or the errors should be normally distributed. Alright, so as you know, I did not mention how we could test the assumptions. Okay, so it is because the specific test to measure or to calculate the assumptions, I discussed it to other video. Okay, so for example, what are the tests to measure the autocorrelation, the homoscedasticity, and so on and so forth, how to detect outliers. Okay, so I will going to discuss this in a separate video. All right, now the question here is that what if any of the assumptions are violated? Okay, so what if any of the assumptions are violated? What are we going to do? Or what this imply? Okay, if any of the assumptions are violated, the forecast, the confidence intervals, and scientific insights yielded by a regression model may be or might be inefficient, or worst, it is seriously biased and or misleading. So this is very important, no? So that is the reason why it is very important that before conducting or building a model, you should satisfy all the assumptions. Okay? You should satisfy all the assumptions needed in a machine learning algorithm. Otherwise, your data or the result in general is not as valid and it's not as reliable as it may seem. All right? So, what happened if there are assumptions that are violated? Of course, there are always solutions. All right? So, in statistics, data transformation is the application of a deterministic mathematical function to each point in a data set. That is, each data point zi is replaced with the transform value yi, where f is a function. The transformation is usually applied to a collection of a comparable measurement. Okay? So, for example, one of your independent variable has violated, and let's say there are a higher number or a higher percentage of outliers. So what are you going to do now to minimize the outliers? Are you going to remove the data that causing the outliers, or you should apply transformation procedures to correct the data? Okay, so again, this procedure will be discussed in other video. Alright, so this is the multiple regression equation. Y hat is equal to beta sub 0, beta sub 1 times x sub 1, beta sub 2 times x sub 2, beta sub 3, x sub 3, plus so on so forth up to k, where the dependent variable, we call it y hat. It is called y hat because this is just an estimate. This is just a predicted value. Okay, that is why we call this as y hat. Hk, or the x value, are called the independent variables or the predictors variable. And the beta sub 0 is the intercept or the constant. And the b is the slope for x. Okay. Alright, so let's proceed to the Excel example. Alright. So I am going to use this dummy data for demonstration purposes only. And let's discuss real data in my other video. Let's assume that we already checked all the assumptions and the data is now ready for analysis. As I discussed a while ago, this is the multiple regression equation. Okay, so that we are going to use, and we will try to calculate the slopes and the intercept using the different Excel formula functions. For us to estimate the beta, we will going to show you how is the X matrix looks like, and the transpose of the X matrix, and of course the Y vector. As you notice in my Excel formula, I already highlighted the area where we are going to populate. Alright? And we will going to put all our computations here. Okay, so first thing is we will going to copy the value of the Y variable to the Y vector field. Okay, so we will going to copy the value of the Y variable to the y vector field. So let's put an equal sign, and then let's put it the value in the B2, and then let's just drag this down. So this is exactly the same as this one. Okay, and as you notice, this is 10 by 1 vector. Okay, so this is 10 by 1 vector. Alright, so we'll also copy the values of the independent variables to the X matrix fields. Okay, so we will going to copy the X values to the X matrix fields. So this will result to 10 by 4 matrix. Alright. Okay, so where are the X? So we're going to copy this. So what we're going to do is just put equal sign here. We're not going to highlights and copy because I'll explain you later. Okay, so what we're going to use this to do now is this yan. Okay, to copy this. And then drag the cursor. So as you can see, 537, 537. And drag down. So this is exactly the same. Okay, so this should be a 10 by 3 matrix. However, you are wondering why I included 10 by 4 matrix here. Simply because, alright, there are only 3 independent variables. So we're going to treat beta sub 0 as constant. Thus, so we will going to treat this beta sub 0 as constant. So we're going to put 1 in each of the observations. So we will treat this as constant. Okay, so it's too much. Okay, so that's all. And then, now, as you can see, we already have the X matrix. So this is the X matrix and the Y vector. Okay, so we still need to perform how to transpose the X matrix. Now, in transposing X matrix, there are 2 ways. Okay, the first method is to highlight and copy the X matrix and then put your cursor to the transpose field and choose the pace spatial. This technique is not useful when you want to automate the calculation. So you notice that when you transpose, your data will not change if you change any of your independent variable. Okay, so I'm going to show you this technique. Okay, so highlight this one, copy or Control C, and then put the cursor here and then right click and then choose the pace spatial. Okay, pace spatial and then transpose and then click values. So the data, the X matrix is now transposed. But as you notice, since you are using this formula or using this technique, no, let's try to highlight this one. Okay, this is this one, and if we try, so this is 1, right? So if we want to change this value into, let's say, 12, so as you can see, the value in the X matrix also change, but the value in the transpose area are still the same. So simply because what we have done is the transpose procedure using values. So this is not a formula based, so it will not change no matter how you change these values. This will remain as is. Okay, so In order to automate this, similar to this one and similar to this one, we were going to use the function transpose. Okay. Let's bring back the value 7. And let's delete this one. Okay. So to calculate the transpose, we need to put our cursor here and then put equal sign and then transpose, open and close parentheses, and as you can see, you are it is asking you to highlight the array. Okay, so you need to highlight the array, and then once that, click shift and then close parentheses, and then hold the shift key and then press enter. So as you can see, this is now a formula base. Okay, this is now a formula base. Okay, so let's try to test. So let's bring back the value. Let's change this into 12. So as you can see, 12 also changed this one, and this also changed. So that is the first function. Okay, let's bring back the 7. Okay, so we're done with the first step. We need to say the definition of the matrices. We're done. Next is how to calculate this one. So this actually this is nothing, no? I am just showing you how this 4x4 matrix arrives. So as you can see, the X matrix and X. So we will going to copy the first number in the matrix and the last in the X value. So it will become 4x4. So that's why this is 4x4. Okay, so how to do this? So we will going to introduce the mmult functions. Okay, so to do this, let's highlight this one. Shift enter, put your mouse here, highlights, and then put your mouse here and then equal sign, mmult. Okay, open and close parentheses. Let's highlight the transpose area. Okay, so as you can see, the formula for mmult, it is asking you to highlight the array 1 and the array 2. So I already highlighted the first array, and then after that, I'm going to click on the comma button, and then I will going to highlight the second array. Okay, and then the open and close parentheses, and then I will hold the shift key and then press enter key button. So as you can see, the mmult is now replicated here. Okay, actually this is just the products of matrix, products of this and this. All right, so the next step is the inverse. So how to do this? Again, we will highlight the area and then put our cursor here and then equal sign, and then let's type m inverse, and then let's highlight the mmult of the coefficient, and then open and close parentheses or close parentheses, and then shift plus enter key, and this is now the X matrix and X transpose. Okay, so the reason why it became 4x4, this is the reason behind. Okay, this one. Second one is how to do this one. Okay, so let's highlight this again, and then put the equal sign, put the cursor here, and then equal sign m mult. Let's highlight the transpose. So as you can see, the formula x matrix multiplied by the vector. So I will going to highlight this one, and then comma, and then this one, close parenthesis, and then hold the shift button and then press enter. So the result now is here. Now, to estimate the end goal of this procedure, we're going to estimate what is the value of the beta sub 0, what is the value of the beta sub 1 or the slope, beta sub 2, beta sub 3, and so on and so forth. So it's only beta sub 3 because our independent variable is only 3. Okay, so how to do this? So let's highlight this again. Put our mouse here, our cursor, and then m mult, open parenthesis, and let's highlight this one, put comma, and highlight this one, and then close parenthesis, and then hold the shift button and then press enter. So as you can see, this is the constant, this is the beta sub 1, beta sub 2, and beta sub 3. Okay, so let's compare the results. So I'm going to copy this, and I'm going to put 3 decimal place. Ayan. Alright, so I'm going to place it here in the sheet 3 because I'm going to compare this one. Okay, so let's put here. Okay, so as you can see, the intercept 7.65, 7.65 is the same. The beta sub 1 is 0.190, negative 0.656, negative 0.656, and negative 0.377, negative 0.377. And if we're going to compare the results in SPSS, this is also the same. 7.965, 0.190, negative 0.656, and negative 0.377. Okay, so let's go to the computation. So the end goal of this value, what will be, okay, so using this formula or the equation, no, what will be the value of y if we put, let's say, 8 in the value of the beta sub 1. Let's use 5 in the beta sub 2 and 11 in the beta sub 3. Okay, so using the coefficient that we computed, okay, so this is now the equation. Okay, so how it looks like. I'm going to use this. Okay, beta sub 0, 7.965 plus beta sub 0, okay, 0.190 multiplied by the x sub 1 beta sub negative 0.656 negative 0.656 multiplied by the x sub 2, and then negative 0.377 multiplied sorry, multiplied by x sub 3. Okay, and we're going to copy this and here. Sorry. Okay, so this is now the value of, okay, so if you're going to apply the okay, so let's change x sub 1 by 8, 5, and 11. Okay, so 8, 5, and 11. So let's change this though. This is 8, 5, okay, sorry, 11. If we're going to apply this equation, the results of this is 2.095. So this is the same as this one. Alright, so that's all, guys, and I hope you learned something in this video. Alright, so in my next video, I am going to show you how to calculate manually the sum of square regression, sum of square residuals, the degree of freedom, the mean square regression, the mean square residual, the F ratio, and of course the significant value or the probability value. Alright, so thank you and have a great day.